So anyway, PV technology is actually pretty simple. I mean, you just have modules here and that produce DC power, and then this is his basement. It comes in over here on the left. This is just a PV disconnect, goes into the inverter, comes out AC. This is a AC disconnect that the utility requires, and then this goes out. This one's actually going outside of the production meter, which is right here. So that pops out on this side. This is another disconnect for safety reasons. If the fire department wants to come out, they'll shut this off. And then this is like the net meter. When you hear of net metering, the meter runs backwards. That's that one. Then the wires come back in the house over here and go back to your service. So in terms of how the technology works in your home, I mean, if you have enough room for this amount of space, which is basically a half sheet of plywood, so it's 4 feet by another 4 feet, you can kind of fit all the equipment. Pretty basic stuff. It also goes in super fast. We were talking about this with someone, we were talking about this earlier, in terms of energy efficiency. You know, energy efficiency is like a lot of work to get it done. I mean, there's like people in your house doing serious work. This whole project got put in 2.5 days. Like people actually on site, like on the roof, and so it goes in really quick. Best properties are southern roof with no shading. New roof is also preferred. Space in the electrical service, that's something that people would be able to tell you once they did a site visit. But basically you actually have to connect the PV array to your service, so you have to have like a breaker space in your service, and sometimes you don't have that, and that incurs an added cost to upgrade that service. Also preferable if you're like living in your home for a long time is the best. This is just a review of solar PV incentives. So there's a 30% investment tax credit. Something that a lot of people don't realize, because depending upon how much your taxable income is you can carry it back 2 years and forward 5 years. A 5 kilowatt project is kind of pretty average for a home. $550 per watt is, it's in the middle. You can get cheaper on residential if it's new construction. You can get much more expensive as well if you need to like upgrade your roof or upgrade your service. And then assuming that you pay 17 cents a kilowatt hour and the electric inflation rate is 5%, the value of that power is about $850. SRECs are worth about $200 a piece when you actually calculate the value, and so your IRR over 20 years is about 15% in this example. And I'll get into a little bit, because one of the things I really wanted to go over is like, if you're going to have work done, like what are the questions to ask contractors, and what, how do you make sure you're getting a good proposal, which is one of the things that you guys are addressing as well. So top 5 questions. The first thing is double check all economic assumptions. Mainly the 2 main things that contractors will try and kind of talk about incorrectly are SREC values and electric inflation rates. And so the risk in saying that is that they'll kind of blow up whatever your returns are going to be, because if they say the SRECs are more valuable than they are, or that the electric utilities are going to go up like 10% a year or 15%, then it looks much better than it is. So being conservative with that is key. Also, what is their roofing experience? This is something that people forget about a lot, but #1 problem with all solar arrays is roof leaks. And like, as much power as you're getting, if your roof leaks, like it doesn't really matter. And when I say #1 problem, I don't mean that that is a huge problem. I just mean that of the small subset that actually have problems. Other question is real-time monitoring and production guarantee. You won't find a production guarantee that most contractors have these days, although I think they'll start to do it as the industry gets more competitive. But a lot of them will offer monitoring. Then asking about number of past projects and NAPCEP certification. This is what I was talking about in terms of cash versus owned versus debt. So there's been a lot of money being put into like third-party leases with Real Good Solar and Sungevity and Sunrun. I think the best reason is that you get it for free. Potential problems are you don't save a large amount of money up front. You save some, so it is better, right? If you're saving $20 a month, that's still $20. So it's not nothing, but just look very closely. Some of them have clauses where there's actually a penalty for moving. So if you get it and then you move within like 3 or 4 or 5 years, or like in a short period of time, there might be a penalty, as well as what the lease inflation rate is. A little better than that in most cases is debt. So through GE Capital or Admiral's Bank, they'll loan you money at 6%, and then you can use that to buy the array. And the reason that's better is they're both no money down, and you end up saving more money per month, and then you actually own the system in 7 years, and they're saving a lot more money. The only really downside of debt is that your returns aren't as good as owning the system. Kind of like buy and far, if you have the cash on hand, it's the best, or wouldn't say best, one of the best investments you can make for the risk level that it is, which is not very risky because you're always going to be using electricity.